My name is William C. Harto, and I am currently attending grade 9 in the Mentari Intercultural School, Jakarta. Today, I'll be educating you guys about the 3 laws of motion. The 3 laws of motion were invented by the great scientist Sir Isaac Newton. These days, the motion of an aircraft through the air can be explained and described by the physical principles that were discovered by the great Sir Isaac Newton over 300 years ago. Newton worked in many areas of mathematics and physics. He developed the theories of gravitation in 1666 when he was only 23 years old. Can you believe it? Only 23, and he already developed the theories of gravitation. Some 20 years later, in 1686, he presented his 3 laws of motion in the Principia Mathematica Philosophia Naturalis. Newton made the laws in order to describe the motion of a body, upon which forces may act and which it may exert forces on other bodies, and it is used as the basis of classical mechanics. In other words, Newton used the 3 laws to describe motion and define the concept of forces. To further illustrate and help you guys to get a better understanding of Newton's laws of motion, I will be showing you guys a video clip from a famous Disney film. First law states that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. This is normally taken as the definition of inertia. The key point here is that if there is no net force acting on an object, if all the external forces cancel out each other, then the object will maintain a constant velocity. If that velocity is 0, then the object will remain at rest. If an external force is applied, the velocity will change because of the force.
WALL-E, an object at rest, was acted on by an unbalanced force when he shot the air from the fire extinguisher in one direction. Here WALL-E followed Newton's first law because he was an object at rest that became an object in motion due to the unbalanced force that was acted upon here. However, Eva disobeyed the first law of motion as when she stopped there was no unbalanced force that stopped her, she just suddenly stopped by herself.
The second law explains how the velocity of an object changes when it is subjected to an external force. The law defines a force to be equal to changes in momentum, mass times velocity, per change in time. Newton also developed the calculus of mathematics, and the changes expressed in the second law are most accurately defined in differential forms. Calculus can also be used to determine the velocity and location variations experienced by an object subjected to an external force. For an object with a constant mass, m, the second law states that the force F is the product of an object's mass and its acceleration. The formula is F equals m times a. For an external applied force, the change in velocity depends on the mass of the object. A force will cause a change in velocity, and likewise, a change in velocity will generate a force. The equation works both ways. So basically, the more force, the more acceleration.